Hello everyone, welcome to this Pandas tutorial. I'm Ho Tin Ong, one of the TAs for the computational statistics for data analytics. So first of all, if you download the materials, which is called a Pandas tutorial folder, you will see a Jupyter Notebook file and a folder called data. So we got two CSV files. So no matter you're using Anaconda, Jupyter Notebook, or VS Code, or any other IDE, it's up to you as long as you can open the Jupyter Notebook file and you will see something similar to me. So you have the code markdown and you can run the cell one by one and you see something similar. And it's up to you. You can choose your favorite IDE. And first of all, before this tutorial, we assume you already have the Python basic. So if you don't have, please refer to another teaching materials called the Python basic. And today we're gonna learn the Pandas, one of the most powerful module in Python. So Python has a very strong open source community. So that means you can share, contribute your code to the others, and you can also download the others' codes if they want to share it. So by using pip install, we can install a module called Pandas to our environment. So if you are using Anaconda, maybe Panda is pre-installed when you are using the Anaconda. So by clicking this, and you will see requirement already satisfied, and that means you already installed it. So in Jupyter Notebook, this is called one cell. A cell can be used as a terminal, CMD, or Anaconda prompt. So this is not a Python. Actually, this is a terminal command. So you can also copy this line of command to your terminal Anaconda prompt to install any other package or modules. And first of all, today we're gonna use a data from from an open data set, which is from this link. So if you open this data, or no matter what data you're working with, it's very important to know the nature, the unit, the description of the data. So let's have a look. The data we are using today is about the flooding. So it's a global flooding awareness system, which is related to river discharge. So let's have a look of this description table. So first of all, we have a data type, which is a gridded data. So gridded data means we divided the whole row, the global map, into a grid, into pixels. So it's something similar you see on the Google map. So for the projection, we are using a regular latitude longitude. That means we are making the sphere, the Earth, to be a rectangle. So we have 经纬度, the longitude and latitude. So for the range is from negative 180 degree to positive 180 degree, and plus 90 degree to negative 90 degree. So for this data, we have a spatial resolution 0.05 degree times 0.05 degrees. It's roughly 5 km by 5 km. Okay, and we also have a global coverage, so it's a very huge coverage, except for the Antarctica. And for the spatial resolution and temporal resolution, so this is a daily data. That means for each location, for each pixel, we have one data per day. Okay, so we also have a update frequency, so it is updated daily. That means every day you have one more new data. Okay, so today we are using the first variables, which is with a name called river discharge in the last 24 hours. And we also have the unit. It's very important to know the unit and the definition. For example, we have a river discharge. So this is a volume weight of water flow. And this is an averaged value in the last 24 hours. So as for the volume weight, we will never have negative discharge. So we won't have negative value if we are using this data. So sometimes if you are clear about the definition of the data or the value, you have a reasonable guess. If you have some problematic data, for example, negative values, you can determine if this is a good or bad data. So it's important to understand your own data, especially for your research. So here is a variable name, meter cube per second. And before we start the section, there's some reminder for people who are not familiar with the Jupyter Notebook. So Jupyter Notebook is an interactive Python code runner, or we call IDE, Integrated Development Environment. So one of the main function of Jupyter Notebook is you can jump and run the cell one by one, and you can jump between different cells. So by running this, you can either click this button, so run or execute the cell, or holding shift and enter. So you run the cell and jump to the next cell automatically. So for example, if you're trying different code, you want to run 10 cells continuously, so you don't need to click 10 times. You can just holding your shift, enter. And second reminder is for comment and uncomment. So adding a hashtag means comment this line, so your computer won't run this line of text as a Python, because they know you just want to write down something which is not a Python code or anything. So they will ignore this line of code. So adding a hashtag, for example here, you can add a hashtag, and this is a remark. Or you have a line of code, remark equal to 1 plus 1, but you don't want to run it first. Maybe you want to test with different code, for example 1 plus 2, and you want to comment this. So by holding control or command, control for Windows, command for Mac OS, so you can comment the line of code, so your computer will totally ignore this free line of code or text. So I think you already installed the Pandas. So there's two importing style. For the first one, we can just import Pandas. So you can see Pandas here is a module we already download. So you can run this. If you have a tick here, success. So it means that you already downloaded Pandas successfully, and it's okay to use it. But if you have some problem, for example, I intentionally to type the names wrong, you see no module named Panda. So if you have this problem, either you type the wrong name or you didn't install this package. So please check if you have installed the Pandas. And another common practice that we always want our code looks clean and short and simple. So it's cool. It's like a hacker. So we can use as this syntax to have a shortened name to replace with the Pandas. So if you import Pandas as PD, you can directly use PD here to call anything from Pandas. So it's up to you. You can import Pandas without as PD, then you need to use Pandas here for all the code. Or you can have a shorter name, just like we import NumPy as NP. And here is the official website of the Pandas. So feel free to check any guideline, maybe API reference, or some example code for you to use Pandas. Okay, so we already import the Pandas, and we can use it. So for the section 1, actually we have 4 sections. Section 1 is about the data inspection. So it means how we're gonna load the data, how we're gonna see or inspect our data. And for section 2, it's a kind of selecting the data, like what we did in with our mouse in the Excel. And for the section 3 and 4, it's more like the about the data frame manipulation, like indexing, filtering, and for data aggregation is for your post-processing for your data, maybe resample. Especially if you're working with time series data, indexing and resample is very important. If you want to extract more meaningful data, more meaningful values from your data. And there are finally some useful resources. So first of all, let's load the data. So if you are using VS Code or other IDE with proper extension installed, so you can do something similar like this. So by moving your mouse on a function, this is some documentation written by the authors. So it's telling you, oh, here's a function called read CSV, and don't be panicked, it's just the input. So what you can tell this function to do. So with the minimum for the basic function, we just want to load a file, right? So we can just by inputting a file path. So here is the data. So that means within the same level of this Jupyter Notebook, there's a folder called data, and we have a file here. So if you're using VS Code, you can copy the path or relative path. So you can place to here to load the files. And if you are using Jupyter Notebook, actually you can search read CSV with Pandas. You will see something similar like this. So it's a guideline to help you for using this function. So just ignore all this input first. And if we scroll to the bottom, we will see something, the arrow and data frame. So this means this function will return you something. So because when we load the file, we will have a variable to store it. So the type of the object they return is a data frame. So that means here I have a variable called glow_fast_grid to save the returned object. So here is a data frame. So I have 2 files and 2 data frames. So let's see, when we open these 2 files, these 2 CSV files in Excel, we have something like this. So this is the data. So actually these 2 files are connected. If you observe the ID columns and the header on the right, so we have 663, 663, 677, 677. So the file on the left is relatively smaller, and actually is a metadata or location information for each unique ID. So you can see the longitude, latitude, and some country, province, some more detailed location, regional information. So for 663, we have this column on the right. So this is the value of the data. So mean discharge volume rate in the last 24 hours. And in the website, we saw that this is a daily frequency data. That means we have 1 data per day. So they match. So here on the left, we have starting from number 2 until 3,697. So total we have 3,696 unique ID. So we already processed this data for you. All the ID is from Guatemala, it's from the same country. And in here we have starting from the B to ELE. So there are 3,696 columns. So they match. So we have 3,600 something grids data. And from the date of first day of 1981 to, that's the problem when you're using Excel. It consumes too much memory and you need to wait forever. So from the first day of 1981 to the last day of 2023. So 43 years and 360 something days per year, we got around 15K 700 data times 3,000 something. So 15K times 3,000 data. So that's why this file is so big and it's not easy to manipulate it or calculate on the right hand side. So let's back to the Jupyter Notebook. If you try to open this data with Excel, it took me maybe more than 1 or 2 minutes. So you can see with Python, it just takes maybe 10 seconds or even 4 seconds to load this file. So this is the efficiency of Python. Okay, so what is a data frame? So obviously we know data and we know frame, data plus frame. So basically data frame is a rectangle table that's storing the data. So for the rectangle, we have the width, that means columns. So in here we have 1, 2, 3, 4, 5, 6 columns and 3,600 something rows. So this is a data frame. So if we load it, and with the Jupyter Notebook, we can easily inspect the data frame. So by running this cell, you can see 3,696 rows and 6 columns. So it's the same as you load in the Excel. Let me see. Yes, they are the same. So data frame is very intuitive, like what you use in Excel, but much more powerful. And if you are open to your CSV file in the maybe text editor, you will see something like this. So we have ID, longitude, latitude, and CSV is a comma separated values. That means they use comma to indicate there are 2 values separately. So your Excel or Pandas will read the position of Pandas, and they will make each separated value as a column. So in here we already load this data frame. So let's check if we can inspect the data frame. So we have 2 methods. One is called head, another is called tail. So for the head, actually is return the first n rows for you. So in here we have a head, maybe 15. So you will see they are returning you the first 15 rows of data. And we have tail, you can inspect the last few rows. So actually the default value here is 5 if you don't have input. So they will return the last 5 rows automatically. But if you want to inspect less or more, you can maybe have an input, have an integer input. So you can inspect the last 3 rows of data. So for a data frame, they have many attributes or property. So the first one is the shape. So rectangle, you have width and height, right? So for these 2 data frames, we have 3,696 rows and 6 columns. So always we have row before the number of columns. So when you are index a data frame, so remember we always put the index of row at first, so columns after. Okay, second attribute is the data types. So if you use the Excel before, you know why data types matter. So let's go back to Excel first. So here is a new file. We have a 3/8. So imagine what happened after I type enter. So normally a new file, no any changes, the default values of 3/8 is a date for general, because this makes sense. We use the slash as a date, maybe a month and a day, right? But what if I change the data type or type of format? You see the number format to be number first. So 3/8. It becomes a number, a floating point number. So, and then lastly, we have set this cell to be a text. So 3/8. It becomes a text with no any calculation or conversion. So with the same input but different type of format. So you can see we got 3 totally different results. So let's back to the cursor. Let's back to the Jupyter Notebook. After we execute this cell, we see like how the pandas read this data. For example, they read the ID as an integer. So 663, 677, yeah, it makes sense, right? You can treat it as a string or a integer. And for the longitude and latitude, of course, you got a point here, floating point here. So 0.15, 0.25, of course this is a floating point data type. And also for country, province, and moon, for pandas, if they meet something non-numerical, so they will treat it as object. So they are not sure about this thing. So sometimes it's string or object. So that's mean the pandas are not really sure about the data type of these columns. And they assume the whole columns has the same data type. Okay. So in here we have the discharge data. So let's see. For the date, so this is the date. So for human, we think this is a date time. Why you think this is an object? That's why we have to check the data types, and we can change it later. So in section 3, we will learn how to change the data type. And for the 663 different columns after B, they are all floating point. So it makes sense because it's a value. But we can know that actually the pandas didn't know this date column is a date time. So you need to be careful and make sure every column is they recognize every column correctly with the correct data type before you do the operation or calculation. Okay, so we also have a columns. So in here, the columns can be converted to be a list or by using this function. So this is something you're familiar with. For the list, you can do the indexing or concatenation or append. So sometimes the columns is quite useful when you are doing the filtering or indexing. Then you will use it later. And finally, there's 2 more inspection function. First one is info. So the information of these variables, this is a data frame, and this is you have 6 columns. For each column, you have a data type. So this is a summary of the data types. We have 2 floating point, 1 integer, and 3 objects. So we also have the memory usage. So this is very small data, just 100 something KB. And for this discharge data, it's 443 megabyte, and it has too many columns, so they didn't list it for you. But you will see, we got all the data after second column. They are floating point. But for the first column, date, this is an object. And for the describe, this is also a very useful function, especially if you have a clean data, you want to have the statistical summary in a very quick time. You can use this function. So you see for each column, you have count mean, standard deviation, minimum or different quantile or maximum. And for this one, you can also convert it to be a values. So it results in a NumPy array. So you can just get the value in this table within maybe 3 or 5 seconds. Yeah. In Excel, you have to scroll it, check the function, and apply it to every column. So you know why we're going to use Python. Okay, now you know how to inspect your data in Jupyter Notebook with data frame. So it's time to move to the data selection. So data selection is something like you do with your mouse in Excel. For example, you want these 2 columns, right? So you can use your mouse, or you want these 10 rows. So you can do something like this. Or you just want this area of data. So you can copy or place or move it to the others or delete it. And something similar here. So in Pandas, we have 3 functions. The first one is called locate. Another one is called iLocate. The I means indexed, so you can use the index to locate some data. And finally, I want to take the whole columns, so I can by inputting a list of columns name and get the data frame. So first of all, here is a locate example. If you run this, the reason why I'm using here is in the country, for the column country, all the data are Guatemala, so I know it's not that meaningful, and I just want the ID, latitude, latitude, and the province, and I don't want the too detailed regional information. So I can input a list of the columns that I want, and this is the ID or the index of the row that I want. So you see, I'm taking a 4 columns data and 353 rows of data. And now if you're using Excel, you are still using your mouse to scroll down, scroll right or left. Yeah, this is the powerful function of one of the powerful function in Pandas. Not only the locate, we also have an iLocate with the index. So let's see this data, this charge data. For example, here I want to take the last 10 rows of data. So it should be the last 10 days of the December of 2023. And I want to take the first 5 columns. So in here, it's same as the index in list. So this is a open end. So 0, 1, 2, 3, 4, but not the 5. So let's run it. 0, 1, 2, 3, 4. So this is open end. So please be careful if you want to maybe also take the column 6. So you need to add another one. Okay. And for the iLocate or locate, actually you can get anywhere of data within the data frame by using these 2 methods, including you want to take the whole column. So I just want to take the 3 and 4 rows, but all the columns. So this syntax allows you to take all the columns. That means taking all along this axis. Okay. So the last one is also very powerful and intuitive. So now I want to take the whole columns. I just take all the rows but different columns, specific columns. So in here, this is a index. So you need to know the exact index of the columns or rows. But in here, the header, the name, column names are more representative. For example, I have a 4 targeted unique ID I want to analyze. So I can take 833, 33, 1004, and jumping forward and backward. So they will rearrange the columns. So you can see, I don't need to care about which column are in front or in the back. I can just take whatever I want. And sometimes you may just want to take one ID data, and you can, by doing this, without a list. And in here, be careful, if you just inputting some index without a list, so you see here's a double bracket, you will get some error. So you must a list, there must be a list of column names here, then you can get 4 columns. So in here, because you got 1, so it's okay, and you can see. And if you want to convert it to be a list, so list operation, something you are familiar with, so you can just use to list, or just making it to be a list. Okay, so here is a in-class practice, so feel free to finish it. And if you or for these 2 questions, you can, for those who are familiar with Pandas, this is so easy for you. And for those who just start learning Python, it's okay with the things that we learn in the above content, and only basic Python, you can finish these 2 tasks. So first of all, for the task 1, you are gonna use the glow fast grids to extract the latitude and longitude columns, for which the location with a odd number ID. So what does it mean? So I want to take the longitude and latitude column of the ID, they end with 13579, so it's the odd number. So be careful, sometimes you have a continuous odd number rows, so the ID, so you cannot just jumping one by one, so you have to think of it. And second one is extract all the columns which are within the February of the 1981 data. So the same, you can use, you can finish these 2 tasks with basic Python, and also the data selection that you learn from the above content. And so if you already finished these 2 tasks, feel free to keep playing, or if you haven't, please pause the video and do it by yourself first. Okay, so here's the explanation of my stupid or more pure basic Python solution. So first of all, we are gonna deal with the ID, right? So I took the ID column and set it or change it to be a list. So we have a list of glow fast IDs here. So this one, we have the IDs, and for each ID in the IDs list, so I will check it one by one. So if this ID, because this is an integer, so if this is divided by 2 and the remainder is equal to 1, so that means it is an odd number. So I'll append the index of this ID in the IDs list. So I will check one by one, is this odd number? Okay, I put 0. If this is odd number, okay, I put 1. If this is not, I will skip to the next one. Finally, I use the locate. So in this task, because I already know I want exactly the latitude and longitude columns with odd number ID. So I use locate, so I can specify the column with their names. And I put the index of the odd ID index. So you see something, all the even number row, almost a half disappear, or I extract half of the data. Okay, so for the second task is using a discharge data, extract all the data along a February in 1981. So let's check. Because these date columns, Pandas read it as a text. So I use these characteristics. So I convert the date column to a list. So I use a for loop. If the 1981-02 in this date, that means this is within the February of 1981. So I use ilocate because I want to extract all the columns. when you're using iLocate, we put the row in front, right? So basically you can do the same with this. So I want this row and I take all columns. They are the same. So in here, February should be 28 rows. And if you remove this, you get the same. Okay, 28 rows. So this is the very small in-class practice. Okay, in section 3 and 4, you will learn a much smarter way to get the filtering, like in the 2 practice. So first of all, let's observe the data again. So for the discharge data, we have a header. That means the column name. So the column name means that we think that this value is the most is the representative of the whole column. I think it makes sense, right? The date is the whole column is about date. The whole column data is about the location with ID 663. And how about the rows? Actually, they use the Pandas use 0, 1, 2, 3, the ranging index as default. So we have this number, this value as the representative for each row. But I think the more representative value would be the date. So this is the characteristics of time series data. You always have a date for your data. So how about setting this value to be the representative of each row? So here, there's a function called setIndex. So we need to specify the name of the column. So here, if your data is time here, you need to use time. It's a string. So here we got date. And for Pandas or for data frame, they prevent you to change the original data frame easily. So if you use this function, either you need to use in place equal to true. That means replacing the original discharge data frame, or just assigning the discharge data to be this. So they are the same. So if you don't do this, if you didn't put in place, they won't change or adjust the original discharge data frame. So let's see what we change if we use this setIndex function. Originally, the index or the representative values of each row is just a ranging index from 0 to 15,704. But in here, we change the index to be a date. Now we can it make much more sense if we use this column's name, this header, and this index to represent the whole data frame. And once again, the data frame or for the date column, Pandas read it as an object, so they don't know if it is a date or string or something. So we want 100% sure the discharge data index is a date time related or in the date time data type. So what's the benefit of date time data type? For the date time, we can have the year, month, day, or some date time wise calculation. For example, 3 p.m. minus 1 p.m. is 2 hours, some kind of calculation or filtering. So by using this line of code, we can assign or we can convert the index to be a date time data type. So we can try, and in here, before we are gonna filter the data within maybe in a year, we need to use the get the date and use some filtering, a for loop. But after you change the date time index, actually just one line of code. For example, target year is 2005. So we put a condition here. Okay. So for all the rows of data, if the year of the index of the discharge data equal to target year, so I will filter it out. So I will only obtain the data within 2005. So let's see. One line of code, and we filtered the 365 rows of data. So you can see, and still the same 3,600 columns. So let's change to maybe 2004. So every 4 years we got one more date. So it makes sense. So if you want to do the yearly analysis, or just want a specific target year, you can do the filtering like with one line of code. Okay, so in this part, sometimes your data is not really high quality, or due to the uncertainty, you may have some missing value. So in this part, I made up a fake data set, which is a 3 columns and 10 rows. So I manually assign some none value. So this means a missing value inside the data frame. So we have two methods or two ways to solve the missing value. Either we drop it, so we remove these 2 rows of data and this row of data, or we fill some value into the missing value. So for the first one, we have a function called drop none. So from 10 rows, 3 columns, to 7 rows and 3 columns. So we are removing the rows with missing value. Or if you have many data and all the data for some columns they have a missing value, you don't want to delete all. You can fill maybe a mean value or a maximum value or minimum value. So you see here is the mean value of the whole column. So we can fill a value to remove the missing value. So feel free to use it, or you can try with different strategies when dealing with the missing value data. So in the last section, we have the data aggregation, resample, and merging. So first of all, sometimes you might not have a processed data. For example, in this situation, I am simulating the data that is provided station by station. So you have all 45 years data, but you have 2 stations in one file, another 3 station data in one file. So you can think of the shape of these 2 data frames. So originally we have 15,000 rows of data, but I pick 2 columns and 3 columns. So this is a data frame with all the date, but only 2 stations. Another one is only 3 stations. So we want to combine it horizontally. So this is concatenate. So this is a function called pd.concate. And for this function, you can input a list of data frame object. So that means, for example, if I have 3,000 station data, which is separate in 3,000 CSV files, then how can I load it? Maybe I just load individual file first and save it into a list and concate it along the horizontal axis. So I can recombine all the data as a whole data frame. So one thing to be noticed, please make sure they have the same number of rows. And the axis here, we have 2 axes. 0 is vertical, 1 is horizontal. So after we combine it, we have the same number of rows, but 2 plus 3, 5 columns. So this is another situation. For example, I have all the station data, but my data is provided month by month. So here I simulate, I have 2 month data. So the February of 1981 and December of 2000. So we have 28 days and 31 days. So here they have the same number of columns, but different number of rows. So I want to stack it vertically. So with the same function, pd.concate. So we have the axis along the 0 axis. So in here, we have 28 plus 31. So the same number of columns, but summed up a number of rows. Okay, and this is the concatenation of data frames. For the second last function, it's a resample. So you see, imagine we have 15,000 rows of data. Is too many data. We cannot really tell the story or find the trend from that. So we want to extract more meaningful value. For example, the average discharge data every month or every year. So we can see some maybe yearly change analysis or some seasonal fluctuation. So in here is a resample function. If you run it, for some people, if you are installing a latest version, you might have a warning like me, or if you are using the older version, you might not have a warning. But you can ignore it, or by changing, you see there's a hints. Please don't use M. M means month, Y means year. So they want you to add a Y instead. So adding a Y, so the warning will be gone. Okay, so by running this, and you can see originally we have 15,000 rows of data, and for the yearly mean discharge data, we are taking the average or the mean value of each station within each year. So 1981, 1982, 1983 to 2023. So 43 years and for 3,000 stations. So now you can pick some specific data and plot it, maybe a yearly change or a monthly change. Okay, so finally, I will introduce you the last function, which is very useful. It's called a merge function. It's something similar to VLOOKUP. When you have two data frames with different shape, you cannot just concate it directly. So here's a simulation example data. So we have a GloFast grid. So here what I want to do is I pick some random years data and some station data. Maybe my target station is just 3 stations, and I just want a 3 years data. Okay. And for the metadata here, they have all the data, all the metadata of all the stations. I don't want that much. So let's see. I extract, I use the iLocate function to get the first, 10th, and 20th rows, and also some random column here. So you will see, okay, I have 3 station data and their mean discharge, yearly mean discharge value in 1981, 1991, and 2001. So we can see 9 values here. So what I'm gonna do here is I transpose it first, basically just flipping along the diagonal line. So I have the ID as the index and the date as a columns. So like this. The reason why I'm doing this, because for the metadata here, I have the ID as a columns. I also need an ID as a column in the data frame we're gonna merge. So we have the same ID column. So what I want is, please help me, I asked the Pandas to do this for me. Please, these 2 data frame, you see they have the same columns called ID, and I want the latitude and longitude, so of the specific ID values. So please help me to find if there are any 663 ID in here, and I want the latitude and longitude. And if any other like row of data is with ID 2059 in somewhere here, please give me back their values, their latitude and longitude from another data frame. So here's the merge. So for the first one, is the merging data reference or the target. This is usually a bigger or more informative data frame that we want to extract some data and merge to the first one for the first data frame. And here we have a on. So on what? This is a reference on the column with a name called ID. Okay. So if you run this, you'll see. Originally, we have a 3 years data and 3 IDs, like in the here. And the pandas help us to find, okay, if any data in the GloFast grids with the same name, like 663 ID, and give me back their latitude, longitude, country, or all the data in this data frame. So it's kind of like the VLOOKUP in Excel, but just one line of code. And of course, if you don't want the country or this the last 3 column data, you can use this line of code. We further reduce or narrow down the columns of the GloFast grids data frame and put it into the merge data. So if you do this, we only getting the longitude and latitude information of the specific ID column. So it's very useful, especially if you have another metadata, or if you have 2 data frame and you want to extract and merge them into a one bigger data frame. So here's the last part for the useful resources. For people who just start using Python or just learn Python and is still a beginner, I have some resources. First of all, just using ChatGPT. Actually, I don't recommend you to use ChatGPT or any AI model as a beginner, because it's too dangerous and you will kind of rely on it. So if you don't have internet, or if you didn't pay, you can't write any code by yourself. So please try to use the Google or ask the question in Stack Overflow. Or the best solution is to read the documentation, because in Python, most of the module you use, like the famous one, the NumPy or Pandas, they have their own documentation. So like the ChatGPT or the AI models, they are not really updated, or sometimes the Pandas, they will change the way that how you will use the API, like the merging or the resample we encountered in the section 3. If they change the laws or change the way we use the API, they write down on their official documentation. So if you have any bugs, first try to Google it first, or try to see the API reference of a specific function. For example, we have data frame. Maybe I want to see the index or the columns. So they have all the examples here. They have some very informative description. So you will know much more than from asking ChatGPT. So here's a tool NumPy. So there's many functions. They write it in very detailed and very systematic way. So feel free to ask or Google it. If you can't solve the problem, see the official documentation. The last resort is asking ChatGPT. Of course, if you have any question, feel free to ask the professor or TA during the office hour. And hope you can learn something from this tutorial, and hope you also enjoy the coding and also for the data analysis. Thank you.